my name is Nikolai Senilov, and today we are going to be exploring Matheson Creek Trail along the Matheson Creek. And we will be starting at Matheson Lake. I'm getting tired of saying that word, but basically we are going to be looking at all of the fun fluvial features of the creek and where it empties. So join me on this adventure.
The water that feeds the creek comes from Matheson Lake, which itself is fed by a number of small creeks in the Wildwood Creek watershed. One interesting thing to mention is that this is actually the largest watershed on the East Sioux Peninsula, at 768 hectares. Water generally enters the river system through surface flow, soil moisture, and surrounding tributaries. The area surrounding the river is super hilly, with the tallest point in the watershed reaching roughly 300 meters. The hilly nature and size of the drainage basin means that it generally carries more sediment than other creeks in the area. This area is densely forested, with surprising lack of human presence compared to the rest of Victoria. The dense root system on the riverbanks prevent the river from meandering too much, but the river still does meander from time to time. This is an example of one of those meanders, where the thalweg has pushed against the edge of the channel, causing an undercut bank. This nick point right here is a great example of a hardened layer of rock that longitudinally interrupts stream flow, which causes the sudden drop in the creek elevation. Due to the high velocity of the rushing water, the rock here erodes at a faster rate than the surrounding creek, causing even more deposition.
So this shot right here is basically a great example of a thalweg. The thalweg of the river is the portion that moves the fastest. And what's really cool about this section of the river is the fact that you can clearly see that the center of the river is the portion that's moving the fastest because the bubbles are moving faster towards the center. And the inner portions are moving slower due to the friction caused by the walls of the channel. Basically, what's really cool that I found about this creek specifically is the fact that portions of it are actually made up of sand, such as this one, and then other portions are made up of cobblestone and larger material, right? So on this portion, the center of the river might be a little bit faster than the surface and the very, very bottom. But on other portions of the river, the very surface would be higher because, or faster, due to the friction caused by the rocks on the bottom of the river.
Part of this diverse ecosystem can be attributed to the region's climate, which is classified as a CSB according to the Köppen-Geiger climate classification system. This means the region has a dry, warm summers and cool, wet winters. The area receives an annual average precipitation of 930.3 millimeters, most of which occurs in November, almost a fifth of the total. The winter months definitely experience the highest discharge rate, as snow melts don't play a huge factor in this basin. Being that the area is right by the ocean, temperatures don't change that drastically from season to season. The highest average daily temperature occurs in July and August at roughly 16.5 degrees Celsius. The lowest occur in January, an arguably comfortable 5.7 degrees Celsius. One super cool thing to note is the surprisingly diverse ecosystem all along the river. Several different ecosystems can be found along this creek, such as swampland, cedar forests, and deciduous landscapes. At the very end of this river is an example of an estuary, where fresh water from Matheson Creek finally mixes with the salt water of Rocher Cove at the mouth of the river. This is a very weird geographic feature, caused by the diverging fault line I discussed earlier. A lot of people would be mistaken for believing this cove was just another lake, until they notice the tidal lines on the sides of the rocks and the seaweed on the beaches. There isn't much of a delta during high tide here, but during low tide, the delta can be seen as sediment carried by the creek is slowly filling up the cove. So here's a map I made using QGIS of Matheson Creek and the surrounding topography. One thing you can immediately notice is just how short the creek is, at only 0.93 kilometers, moving from Matheson Lake to Rocher Cove. Another interesting thing to note is the fault line Matheson Lake and Matheson Creek lie on. This fault line splits part of East Sioux Peninsula from the rest of Vancouver Island and creates a valley-esque shape that the creek runs through.
Thank you for coming along this journey with me today. We are standing at the end of the estuary here at Matheson Park, and we followed along the entire creek, learned a lot about nick points, thalwegs, and Right behind me, the estuaries. We've learned that the fault of that splits Souk East Park and Vancouver Island basically follows the same path as the river. We learned that this is the main draining point for much of East Souk, and now we are going to go and have an amazing dinner together with my cameraman. Thank you very much. I hope you have a great day.